Welcome to This Explainer. Today, we are taking on a very specific persona. We are taking on the role of the photographer. Now, what exactly does that mean for you? It means we are going to learn how to frame your Cambridge computer science answers perfectly. We are going to find that exact ideal angle to secure top marks on one of the most notoriously tricky high-level topics in the entire syllabus, how interrupts are handled during the fetch-execute cycle. Grab your notebooks, adjust your focus, and let's get ready to capture those marks. And listen, whether you are looking back at foundational concepts from the 0417, 0478, or maybe the 0983, 0984, and 2210 syllabuses, or you are right here in the thick of the advanced 9618 syllabus, the methodology we are talking about today is absolutely universal. It is the absolute core of algorithmic thinking. Okay, let's adjust our lens and look at this insider blueprint. To set the scene, let's look at a real Cambridge computer science past paper question. Specifically, we're pulling from a classic 9713 style scenario. The question asks, describe the sequence of events that occurs when a hardware interrupt is received during the fetch-execute cycle. Now, I want to introduce you to two typical students facing this exact prompt. First, we have Alex. Now, Alex is a hard worker. Alex overloads his answers with raw computer science facts. He'll write a massive paragraph about what a processor is, what an accumulator does, and what binary is, but there's absolutely no analysis, zero. Then, on the other side of the exam hall, we have Sam. Sam rushes. Sam looks at the clock, panics, and completely misses the command word requirements. Sam writes, the computer stops, does the interrupt, and goes back. Both of these students are losing massive points. The quote on the screen right now is a direct warning and, quite frankly, a promise from the senior examiners themselves. They are telling us that students exactly like Alex and Sam are constantly leaving easy points on the table. Their answers are deeply flawed, covered in red pen marks from the examiners. But by the end of our time today, you will have the exact framework the examiners are looking for. You won't be one of those students losing out. Here is our roadmap for today. Section 1, the examiner's warning. Section 2, core principles. Section 3, technical methodology. Section 4, examiner insights. And finally, Section 5, the ultimate exam strategy. We are moving fast, so stay with me. So, why is interpreting complex binary representations in hardware states such a massive stumbling block? This is the exact question examiners ask themselves when grading papers. Think back to Alex and Sam. Alex knows the facts, but can't apply them to a complex binary state. Sam doesn't even try to read the data deeply. We are going to decode the logic behind this struggle right now. It's about knowing how to read and trace CPU states without losing the big picture of what the entire system is actually trying to accomplish. Section 1, the examiner's warning. Let's zoom right in on the top pitfalls straight from the principal examiner reports. Let's look at the hard data on where students are bleeding marks. You literally must avoid these three specific traps if you want top grades. First, overly vague answers. Remember Sam, the computer stops and does the interrupt. That is way too vague. Examiners do not want generalities. They want specific technical details about how the hardware handles the interrupt. They want to hear about registers, flags, and system buses. Second, students constantly forget to check boundary conditions and edge cases. What happens if multiple interrupts arrive at the exact same millisecond? What if a software interrupt triggers while a hardware interrupt is processing? If you don't address the edge cases, you lose the top band marks. And third, ignoring the specific context. If the question gives you a specific hardware scenario, say a printer out of paper versus a critical hardware failure, your answer must anchor directly to that scenario. Don't just give a textbook definition. Context is everything. There is a massive examiner alert on this topic, guys. Candidates consistently confuse key terminology. You cannot build a strong answer on a weak foundation. Now, I want to introduce a game changer here, the Peel Framework Overlay, Point Evidence Explanation Link. But here is the secret. Before you can even make your point in the Peel framework, you must define your terms. If you don't define your terms before using them in extended responses, you will lose marks. Don't just throw around terms assuming the examiner knows you understand them. You need to explicitly define that the program counter, or PC, holds the exact memory address of the next instruction to be fetched. You need to define that the interrupt service routine, the ISR, is the specific block of code that handles the interrupt. Lock in that foundation to show true expertise. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Section 2, Core Principles and Logic. Let's shift our focus to the academic benchmarks that structure everything you write. Think of this as adjusting your depth of field. The Cambridge Assessment Framework prioritizes analytical depth over superficial breadth. You must demonstrate a connected understanding across these three cognitive domains: knowledge, application, and analysis. And this is exactly where our Peel framework shines. Knowledge is your point, application is your evidence, analysis is your explanation and link. Memorizing facts like Alex isn't enough. That only gets you the knowledge points. You need to apply reasoning to entirely unfamiliar hardware contexts. Top-performing students exhibit an understanding of the processor that translates seamlessly, no matter what curveball scenario the exam throws at them. They decode the command words perfectly. If the command word is evaluate, they know they need to hit that analysis domain hard. Section 3, the technical methodology. It is time to secure what the examiners call the method mark strategy. Okay, watch closely. While the syllabus generally talks about algorithms and implementations, when dealing with processor architecture and interrupts, we adapt this procedural framework into tracing a hardware cycle. Examiners look for a step-by-step sequential breakdown. This is where those red pen marks turn into green check marks. You actually get points for the process itself. Imagine a 60-second timer on your scroll right now as we rewrite Alex and Sam's answers live. Ready? Step 1. Identify the interrupt flag. The current instruction cycle must finish first. Step 2. Suspend the current process and check the interrupt priority. Step 3. This is the critical one. Save the current register states, like the program counter and accumulator, to the system stack. Step 4. Load the program counter with the start address of the ISR. Translating a general framework into this rigid hardware procedure is exactly what secures those process-driven method marks. You are literally showing the examiner the exact sequence of events, perfectly aligned with the Peel framework. And this brilliantly illustrates why data tracing skills are so critical. When you are faced with a processor diagram or a block of memory addresses, you must be able to track the contents of the program counter and the system stack step by step as the interrupt is handled. You have to extract the binary data, perform the calculations to find the next address, and draw your evidence directly from the given processor state to form a solid conclusion. This is the ultimate proof of understanding. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Section 4, Examiner Insights and Critical Analysis. We are moving into the deep end now, elevating from basic knowledge right up to high-level evaluation. Welcome to our interactive workshop segment. I want you to actively participate here. Let's look at the difference between an average response and a top-tier candidate. For Challenge 1, we are doing a data scan. Imagine a complex data table on screen right now showing interrupt response times. You have 60 seconds. What's the core trend? An average candidate just identifies the facts. They see the time complexity and maybe spot an edge case. But a top-tier candidate, they see the trade-offs. Now for Challenge 2, find the flaw. I'm going to read a flawed paragraph from our student Sam, and I want you to spot the sentence losing marks. Sam writes, "When an interrupt happens, the CPU immediately stops the current instruction, jumps to the ISR, and then jumps back using the program counter." Did you spot the flaw? The CPU does not immediately stop the current instruction. It finishes the current fetch execute cycle first. Furthermore, Sam failed to mention pushing the registers to the system stack. That is a massive loss of marks. A top-tier candidate acknowledges these limitations and rigorously justifies their decisions with evidence. When you are asked to evaluate or compare, you have to follow the comparative analysis rules. This brings us to Challenge 3 in our workshop, speed writing. You have 30 seconds to mentally draft one perfect Peel paragraph comparing hardware versus software interrupts. Go. Time's up. Did you identify both similarities and differences? Did you use comparative connectives like whereas, however, or in contrast? You cannot just list features side by side, you have to link your evidence logically. Support every single comparison with evidence from the CPU's actual behavior. And finally, draw concrete conclusions about their relative importance.
This structured reasoning is what pushes your grade from an A to an A star.
Okay, let's lock all of this in with a highly effective memory hack. You need to create a custom acronym for the specific procedural steps of handling an interrupt. Think about the sequence we just built. First, you finish the current instruction. Then you check the interrupt priority. Then you push current register contents to the system stack. Then you load the program counter with the ISR address. And finally, you restore the state afterward. FCPLR. Finish, check, push, load, restore. Create a catchy phrase utilizing those steps. Something silly, something memorable, so you can instantly unpack them under extreme exam pressure without missing a single beat.
Section 5, Ultimate Exam Strategy. It is time for the blueprint finish. We are pulling all of these techniques into one cohesive system.
This table right here is your ultimate cheat sheet graphic. It is your mental screenshot for exam success. Let's adapt these core programming pillars into our triple R rules that guarantee top marks. Rule 1, command word decoding. You have to break the complex problem down into logical parts based on exactly what the command word asks. Describe requires different depth than evaluate. Rule 2, Peel framework application. Just like selecting the correct data structure for a context, you select your point, evidence, explanation, and link to perfectly structure your technical knowledge about the CPU registers and stocks. Rule 3, time management matrix and rigorous testing. You must ensure you are efficiently managing your time to check those edge cases. What happens with simultaneous interrupts? Test your logic before you move to the next question. This is the complete computer science answering system.
As we look at this final question on the screen, ask yourself, have you defined your terminology? Have you checked your boundary conditions? Have you applied the method mark strategy? Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.